This lesson is going to be pretty quick. We're going to be talking about how to set up a ribbon and the differences between a ribbon and standard joint deformation. The primary advantage of why you would sometimes want to use a ribbon instead of just joints is because of the way in which it automatically rotates deformation instead of skewing it. So I have a demo set up here where you can see the difference. So if I translate this guy right here for the top piece of geometry here, you can see that if you look at the vertical spans here, they're all staying completely vertical, and every vertice on here is moving straight up and down. Whereas if I move the bottom one, you'll see that it has a nice curved fall off and is more natural and maintains a lot more volume. So before it breaks, you can pull it a bit more farther than this one. See how much more volume that maintains? So we're specifically talking about ribbons now because it's what I use to set up lip controls. For lips, you can get away just fine by using normal joints. Right now I'm using a ribbon, so we're going to walk through how to set one up. But again, if you want to just use joints for lips, that's probably totally fine. So the way a ribbon works it's actually pretty simple. You have driver joints, and then you have bind joints. So let's actually make our bind joints visible. Ignore all this now, this is not really structured right now. So our bind joints here are driving the deformation of this plane. So if we were to enter skinning mode for this plane, you'd see it's just weighted between these three, so that when you pull any of them around, it moves it like so. Then what you do is you assign a hair follicle, one per plane, and you tell these bind joints to ride it. These bind joints are what you're going to be actually skinning your character to. So if you look at the local rotation axes here, the XYZ representations, you'll see that they rotate, and they always essentially aim at each other to create this natural hill, this fall off, so that it doesn't just skew. And that's just how follicles happen to work. So because of that, you get that nice natural volume maintaining fall off. So let's go through the process of setting this up now. First thing we're going to do is create our plane. You could go create NURBS primitives. I think you can probably use polygons too. I've had better luck with NURBS though. Plane. Now there are plenty of different styles of ribbons with different amounts of driver joints and stuff. I'm going to set the width to 6 and the length to 1. One of these two is always going to have to be 1 because you want it to be 1 by however number of spans, which represent how many bind joints you want. Whenever I've tried to initially create it with the width being 1 and length being the number of spans, I've had issues where the follicles don't correctly rotate to follow every direction. Now, you can always completely reposition and rotate your ribbon after you create it. You can just import them and reuse them and everything. So there's no reason to be picky about creating it in the right position right now. So just go ahead and set length to 1 and width for however many bind joints you want. And now you're just going to make the bottom match this exact number. 6-1, 6-1, 8-1, 8-1, whatever you want. Leave this set to cubic. I'm going to set this for Y. And everything else is fine. Cool. So we've got this guy here, 6 on the X, 1 on the Z. Now I'm just going to freeze the transformations and delete the history. And we'll call this ribbon geo. The next thing we're going to do is create our 3 driver joints. One joint there. I like to make these noticeably bigger than the bind joints just for visual representation. Since this plane was created right along the grid, I can just hold in X to grid snap it over here to one end, duplicate it, snap it to the other end, and the third one we could have just left in the middle. It goes right in the middle. And because we didn't rotate, there's no need to freeze transformations, so let's go ahead and rename them. Let's give this one the name ribbon001 drv. Copy that, iterate up, and again. Now let's just give each of these joints a locator or a group or both above it using that same script we've been using. And if you're curious about how we did that, all I did was snap a locator and a group to the same position right above it and froze their transformations. So next up, let's create the follicles. Just select your NURBS plane, go under Dynamics, or actually N-Dynamics if it's a newer version of Maya, and under N-Hair, Create Hair option box. Make sure these two numbers match the spans that you created your plane with, so 6 and 1. Leave everything else around here normal, just NURBS curves, you don't need any paint effects. This will be dynamic by default. You can just set it for static because in the end, none of this hair stuff is going to matter. We're just going to be stealing follicles out of it. So none of this matters. Just make sure it's 6, 1 or whatever you set that for with the plane. Grid NURBS curves. Whoops, didn't have this selected. There we go. So you'll see it gave us a whole bunch of stuff over here. It's going to give you a nucleus solver. You can delete that. A hair system, delete that. And the output curves. So all you have left is this follicle group. And under each one there's just an empty group. You can leave it if you want, it does nothing. Feel free to delete it though. So if you select these follicles and turn on local rotation axes, and then go ahead and just soft select to move some of this stuff to make sure it's behaving properly, they should rotate to follow. Alright, good that way. And good that way. Cool. We're good. You can go ahead and disable these. Alright. Now there's a trick to creating joints beneath these. If you select one and just type joint, Maya will stick one right underneath it in the hierarchy at the same position. Let's lower that a bunch. Then do that for each one. Cool, now we have all of our bind joints here. Let's just rename these. Let's call this ribbon001 fall. Two. And same for the joints, but end it with bind. Good. Let's call this ribbon fall group. Group these together. Center the pivot. It already is though, since we're at the center of the world. Call this ribbon drive group. And then group all of them together and call it ribbon group. So now we have everything set up and we just have to skin this. So let's select our 3 drive groups. Select the plane. All your default options should be fine. It's just 3, so you could easily adjust it if it's not how you like it. Looks pretty good though. Let's just turn on local rotation axes for these joints just to make sure everything's working. Great. One last thing to keep in mind is that when you're positioning this ribbon, and you can put it anywhere, it's very easy to manipulate, you're just going to be moving the drive group. So you might actually want to keep this outside of the hierarchy, stick this ribbon one in some miscellaneous group that sticks in the world, and then just true parent this ribbon as like a spine or lips or anywhere else in the world. You can just move it around, rotate it, and scale it. Actually, that reminds me that there is one thing we forgot to do, and that is to make sure the bind joints scale when the driver joints are scaled. So if we scale this down, now this plane scales, but remember it's the actual character's geometry that's bound to the bind joints, not the drivers. The plane is just something that we're using to create follicles on so that we have something for our bind joints to follow. So you have to do some sort of cheat to get the bind joints to follow. And there's probably better ways than the way I do it. I just kind of use scale constraints to balance them between each other. So let's say these ones right here, let's actually zero this out. These ones right here are so close to this one that I'm just going to use this joint or locator, it doesn't matter. It's probably a little bit more stable to use the locator actually, to apply a scale constraint to each of these. Leave maintain offset off. Add. Should probably be doing this while this is back at its 0 position though. And now a scale constraint on this one as well. So now those joints scale with that locator. And now I'm going to do it for the ones right next to the tips. I'm just hitting G to repeat. And now all we have to worry about are these two. And to do that, I'll evenly scale each of them between their two neighbors, which already have scale constraints on them. So now if we set this one to 2 and check this one, it should be at around 1.5. Now let's do it again for this one. And that should be it. So as I was saying, the drive group can be moved, scaled, and rotated. And you can stick this anywhere you want. So let's just hop over to some other versions of ribbons that I've created to just show you that some of the other usages that they have besides just this 3 driver setup. Here's an example that I made in a ring. So I just created a NURB cylinder and deleted the top and bottom. And then there are, let's see, looks like 8 driver joints. And between each driver joint looks like there are 2 bind joints. Right here we have an example of the kind of ribbons that I use for an actual lip rig. I use 5 driver joints for the top and 5 for the bottom. So there's the major middle one. You got this guy, and then 1 more for the outer area, and then there's just a few standalone joints outside of the ribbon for some really specific areas in the corner. And one other thing to notice is that the 3 middle ones on each lip are in its own group that can be moved together. I'll just break these real quick. And that'll move the whole upper lip area in a nice way that's animator friendly. So those are some quick rundowns on the kind of uses I have for ribbons. One last thing I'd like to point out before we move on to actually skinning the lips is that there's a much simpler way to get really nice deformation with volume retention and that nice curved fall off we've been talking about, and that's to use wire deformers, or I believe Maya calls it just the wire tool, where you just create a curve and you just paint one mass lump of influence over, say, the whole upper lip, and then you just control each CV with a cluster. However, there's a big downside to that, which is that you can't rotate. It's only translation. And I think for a lot of animators that would be a deal breaker to not be able to rotate lip controls. So that's the reason I use ribbons instead of that. Okay, so let's move on to painting the lips.